All right, welcome back. We're shooting a third order differential equation here, solving it with Laplace transforms. So we've got this joy right here, and you'll see once we do this why we typically do second order, because this is all the stuff that you could have learned in algebra and probably didn't, because we simply don't teach it anymore. Mostly because this deals with solving problems from the 19th century and early 20th century, and we don't live at that point anymore. So we have to take Laplace transforms of both sides. So we're just going to do that. Okay, so take Laplace transforms of both sides. Right, we're going to isolate our y of s. Okay, so we're going to have some kind of a function of s on the right-hand side. This is a typical big step in, it's a typical hurdle in almost every problem, is we get to use partial fractions. Okay, this is not always going to happen, but mostly it's going to happen. Okay, in almost every actual problem you're going to do, that's what's going to happen. So we're going to look at some partial fractions here in order to turn it into table form. Okay. And then finally, we're going to take inverse Laplace transforms, right, in order to get our function in terms of y of t. Okay, so it's effectively the same sort of steps every time we're going to do this. Okay, so take the Laplace transform on both sides, solve for y of s. Okay, get it into things that actually look like you can untransform them, inverse transform them, and then get to our y of t. All right. So notice here, right, third order differential equation, we have a couple of pieces of things to know. So y of 0 is equal to 0, y prime of 0 is equal to 0, y double prime of 0 is equal to 1. All right, so taking our Laplace transforms here. Okay, so this is going to be 2, and then we've got to look on our chart. Okay, and again, you are going to have access to a chart of Laplace transforms. Okay, this is going to be provided for you on an exam. All right, so if you're doing your homework while looking at this chart, you were exactly in the right place. Okay, now reading the chart, that's a tough thing. Okay, so 37, right, transforming a derivative, even the second one is on here. So hopefully you've memorized them because you've done them so often, but if you need a little reminder, it's right here. Okay. So this is Sn f of s minus Sn minus 1. So we go down a power of s, and we start counting up our derivatives. So this is the basic function, first derivative, second derivative, third derivatives, and so forth, with our Sn's counting down. Okay. So that's how we're going to do that. So this is going to be, right, third order. So this is s cubed y of s minus s squared. Now we're going to start counting up. So this is just going to be y of 0 minus s y prime of 0 minus s double prime of 0. Okay. We're going to have plus 3. Okay. This is going to be s squared y of s, okay, minus s, powers went down by 1. Okay, and that's just going to be y of 0 minus y prime of 0. Okay, minus 3, and it's the first derivative, so this is s y of s minus y of 0. Okay, and now we have finally plus 2. I believe the plus is a minus, it's minus 2. Minus 2 y of s, okay, and all of this is equal to e to the negative t, which is 1 over s plus 1. Okay, and again, we go through and do this. E to the at, a is negative 1, so we have s minus negative 1 here. Okay, so that's what we have over here. All right, fantastic. So Yeah, the first thing to do is to start rounding stuff up. Fortunately, in this problem, there's a lot of zeros, so we don't have to do too much with this. So the only time we actually really need, like that's zero, that's zero, that's zero, that's zero, that's zero. The only thing is this one is 1. Okay, so let's go ahead and ease that into our problem here. So what do we have? We have y of s, right? And now we're going to have 2s cubed, right? 2s cubed plus 3s squared minus 3s minus 2. Okay, and I wish there was like a cutesy little thing here, but there really isn't. To factor. There might be. Okay, maybe we can group them a little different. Oh, forgot this. So minus 1. So what we're going to do, minus 1 equals. Okay, so what I did here is I just took all the, oops, not minus 1, minus 2. I made that mistake before I did this problem. All right, so what I did is I just pretty much multiplied through, right? Multiplied through here and collected all the terms that had a y of s in it, and realized that this term was going to be common in each of these polynomial terms with s. Okay, and then the only extra term I had was this minus 2, right? Minus 2 because of this one, so that's going to slide over, and that's how we're going to do it. Okay, so this is going to be equal to 1 over s plus 1 plus 2. Now, I just want you to realize, right, when we divide by this, we have a choice. We could solve one partial fraction problem with all of these little pieces in it, plus this one, so we could have this one and this one, or so we could solve two of these things, one with all of these terms, one with all of the terms over here, or we could solve one of them. I recommend solving one of them. So what I'm going to do here is I'm going to go ahead and get turn this into like one fraction rather than two fractions. So this is going to be equals 1 plus 2s plus 2 all over s plus 1, which is going to be 2s plus 3 over s plus 1. All right. So this is it. You know, everybody will ask me, like, is there an easy way to do this problem? No, this is it. Okay, this is awful, and it's just the way it is. So we have okay, and we have 2s plus 3, and this is over, right? We have s plus 1, and then here we have 2s cubed plus 3s squared minus 3s minus 2. Like I said, there might be a cutesy thing we could do with maybe pulling this apart with the difference of cubes, and then we might have a thing going on here. I don't know though. I don't think we're going to get out of this really that easily. Okay. So one of the things you could have learned in college algebra, I say could have learned, not should have learned, because quite honestly, my community college stopped teaching this, so we didn't do this. But we have something called the rational root theorem. Okay, you may have learned it in high school. I learned it in my pre-calculus class. To this day, I still resent it because even back then it was not a lot. But what you're going to do is you're going to take the coefficient, the last coefficient, so this is plus or minus 1, plus or minus 2, right? The factors of my last problem, my last thing. And you're going to divide them by the factors of the first value, plus or minus 1, plus or minus 2. So we have to mix and match all of these, all right? So we have plus or minus 1 over 2, right? Plus or minus 2 over 1, plus or minus 1 over 1, or plus or minus 2 over 2. These are all the different factors. Now in this case, some of them go away. So what we're looking for, these are the possible rational roots. Okay, so we have plus or minus 1/2, plus or minus 1, plus or minus 2. Okay, so we only have to do 2, 4, 6 synthetic division problems, potentially, in order to make sure we track down all the different rational roots. Okay, I still remember the guy who taught that I had that did this, and he would put things like 12s and like 6s in here, or 49s or something. So you would be faced with several options. And this only tells you the rational roots. So if you don't have rational roots in an equation, this is not going to give you any answers. Okay. Like I said, fortunately, we have computers now. They're solving polynomials is very, very fast. We don't really have to do this technique anymore. But, it's here if you ever want to torture yourself. One thing that I do know, this might be the rational root theorem. The remainder theorem. Okay, the only people I know that use the remainder theorem on a regular basis are math teachers. And what that means is if I plug a value in here, that's going to be the remainder I'm going to see, right, is the same thing as dividing by that term. Okay. So if I want to do if I want to pull like an s minus 1 out of here, right, we're going to have a 1, right? We have a 2, 3, -3, -2, right? This is s minus 1 to pull out of here, right? Because it's s minus c, and that'll give us all of this for synthetic division. So this will pop down, right? We have 2. 2 times 1, 1 times 2 rather, is 2. Add them together, we have 5. 1 times 5, right, is equal to 5. -3 plus 5 is 2. 1 times 2 is 2. Add them together and we get 0. Okay. By the way, this is why I would not put a third degree polynomial or third degree differential equation on your exams, because this is kind of nuts. Okay. Expecting you. I used to do this when I first taught this class. I assumed people knew how to do this still. Okay, so the remaining polynomial here, right, is we have an s minus 1 times this bit here. Now, the other thing that this was supposed to teach you in college algebra is that sometimes, you can use a technique until you get a partial answer here, and then you use a technique that you already know how to do, like factoring, to finish it off. So if I want to factor this, right, we're going to multiply the first and the last number. So 2 times 2 is 4. And I need two numbers that multiply out to 4, but add up to 5. How about 4 and 1? So this is going to be 2s squared plus 4s plus 1s plus 2. Here I can pull 2, right? Then we have 2s out of here. And we have s plus 2 plus 1 times s plus 2. So if I wanted to factor this fully, we have s minus 1. We'd have s plus 2, and now we'd have a 2s plus 1. Okay, now let's add to the fact that there's an s plus 1 in here. So the problem we're actually trying to solve is we have a 2s plus 3 here, and we have an s plus 1, and s minus 1, and s plus 2, and a 2s plus 1. All right. Now we got to do partial fractions on this, because we have an a over an s plus 1 plus a b over an s minus 1 plus a c over an s plus 2 plus a d over a 2s plus 1. Okay. So far, it's been a lot of algebra. Okay, the differential equation part is actually pretty easy, right? We took the Laplace transform. When we get done, these are easy inverse Laplace transforms, aren't they? So figuring out the A, B, C, and D, that's the part that's going to be a pain. Okay, let's go ahead and multiply through and by common denominators, and let's just go ahead and have a go look at what's going on here. So we have our A, and then if I multiply through, the only one that's not going to be there is s plus 1. So we have s minus 1, okay, plus b, oh, sorry, Getting ahead of myself on that one. It's a whole list of them we got to deal with. Okay, so s plus 1, s plus 2, 2s plus 1. All right, here's our b. The only one that's not going to be there is s minus 1, so we have s plus 1, s plus 2, and 2s plus 1. Okay, we have a c. Okay, and the only one that's not going to be there is a 2s plus 1, so we have s plus 1, we have an s minus 1, and then we have a 2s plus 1. Okay, last one, d, all right, and then that's going to be s plus 1, s minus 1, s plus 2. Right? And this is all equal to 2s plus 3. Now, normally I'm not a big fan of using the shortcut. However, in this case, multiplying all of this out and then solving the 4x4 equation that's going to resolve from it sounds absolutely delightful, and nobody should really be allowed to have that much fun. Okay, so what we're going to do is we're going to use the shortcut method, and it's going to cut down a lot of what we have to do. All right, so what we're going to do first is, why don't we just set s to be -1. Why -1? Notice I put -1 in here. All of these terms go away, right? So what we have is we have a -1 minus 1, -1 plus 2, 2 times -1 plus 1. Okay, and this is equal to 2, -1 plus 3. All I did was set s equal to -1. Right? All of these terms are going to end up as 0. -1 over here on this side as well, and we're just going to solve for a. Right? So we're going to have a, right, -1 minus 1. So if you're $1 in debt, you spend $1. You are now $2 in debt. Congratulations. This is going to be a 1, right? -1 plus 2. $1 in debt, you gave $2. You're not in debt anymore. They owe you money. 2 times -1 is -2. -2 plus 1, -1. This is equal to -2 plus 3. So this is 1 is equal to 1, 2 negative signs. So this is 2a is equal to 1. A is equal to 1/2. All right. Now we're going to put that off to the side. And we're going to repeat this for all of the other coefficients. All right. 1 second here. Pause. All right. Hopefully that'll fix. All right. So what we're going to do now is we're going to figure out what we're going to need for b here. And it looks like if I type in s is equal to 1, so we're going to set s equals +1. Okay. So if I look at s equals +1, right, the a term goes away, it's 0. The c term goes away, it's 0. The d term goes away, it's 0. Okay. So we're going to have b times 1 plus 1, 1 plus 2, and 2 times 1 plus 1. On the other side, we have 2 times 1 plus 3. Okay. So we have b 2, 3. 2 times 1 is 2. 2 plus 1 is 3. Okay. And that is equal to 2 plus 1 is 3. And then, sorry, 2 plus 1 is 2. Plus 3 is going to be 5. That's what I meant. So what is this? This is going to be 9, 18. So 18b is equal to 5. B is equal to 5/18. Okay. Set s is equal to, looks like -2, the next one, right? That'll cross out a, b, and d. Okay, so let's set s equal to -2. So we're going to have c, right? So -2 plus 1. Right? -2 minus 1. Right? I don't want you to look at this and say, oh, I would never be able to pull all of this out of my head at one time. Like, yeah, I know. But you've never been asked to. Okay? So this is not something where I would expect somebody to say, well, obviously you should know this. We showed it to you once. 2 years ago. Why didn't you remember? Like, no, that's not how this works. All right. So this is 2. There's a negative 2 here plus 3. So let's see what we got. We got C, negative 2 plus 1, negative 3. This is negative 4. Negative 4 plus 1 is negative 3. And this is equal to, this is negative 4 plus 3, so negative 1 over here. There's 1, 2, 3 negative signs, so this is negative 9. C equals negative 1. C is equal to 1/9. Okay. At most I would do is we'd have to come up with a DE that we'd have to come up with a differential equation that was like factored by grouping kind of a thing. Okay, because there's a lot here. So let's set S to be negative 1/2. That'll, right, if we set S to equal negative 1/2, that'll knock this out, this out, and this out. Okay, so at D, we're going to say set S is equal to negative 1/2. All right, let's see what we got here. We've got D times, and now we have negative 1/2 plus 1. All right, we have negative 1/2 minus 1. And we have negative 1/2 plus 2. All right. And on the other side, we have 2 times negative 1/2 is 3. All right. So we have to work some arithmetic out here. This is a 2, right? So what do we have? We have D. Negative 1/2 plus 1 should be 1/2, right? This should be negative 3/2, and negative, right, $2 minus $1.50 should be $1.50, right? $2 minus $2 minus 50 cents. We have $1.50 left. This is 2 times negative 1/2. That's minus 1 plus 3, so that's going to be 2. Okay. So what are we going to have here? We have D. One of these were negative. Only one of these were negative, I guess. Okay, I'm not going to complain. So 3 times 3 is 9. So we have 9/8. I think it's negative. Is equal to 2. So we have D is equal to negative 16/9. Okay. So there's all of our coefficients. All right. Now you can write the coefficients on top, and a lot of places do. That bothered me when I was doing this stuff. So you could have, right, y of s is equal to 1/2 over, what is it, s plus 1 at the beginning. I looked at this, tried to integrate it, and this part right here threw me off. Okay, and especially if it's going to be like a scarier fraction, it really threw me off. So I decided that, well, since 1/2 times 1 was still 1/2, I'm going to go ahead and write it as a coefficient. Because now if I had to do a u substitution or something else in here, it was real easy for me to integrate. That's why I pulled this apart. Okay, so there's my A. My B was 15/18, so we have plus, or 5/18 rather, not 15. 5/18. Okay. This was s minus 1. 1 over s minus 1. I gotta pause for a moment. All right, there we go. Get my coffee. For C, that's s over s plus 2. What's C? C was 1/9. So we have plus 1/9, 1 over s plus 2. And I'm going to do something weird for D here. We have minus 16/9. And technically, right, it's 1 over, what was this, like 2s plus 1 or something? Double check here. 2s plus 1. But that's not a form we have, right? We have s minus something. So what we're going to have to do is we're going to have to actually pull out the 2 here. So this is going to be negative 16 ninths, and then we need 1 over 2. Then we have s plus 1/2. You see where the 2 goes here? And that's going to cancel, so we have minus 8 ninths, 1 over s plus 1/2. Right? Then we have 1/9, 1 over s plus 2, 5/18, 1 over s minus 1, and then 1/2, 1 plus, okay. Okay, because the table only has like an s minus something, it doesn't have like a as plus b down here, it just has s. Okay, those are your choices, s. All right, now we're going to go ahead and take inverse Laplace transform, so we're going to get y of t, right, is equal to 1/2 e to the negative t, right, because it's s minus what's going on here. And we have plus 5/18 e to the t plus 1/9 e to the negative 2t, right, that's here, okay, minus 8/9, and this is e to the negative ½ t, right? And there you go, there's our differential equation solved. Okay, there's a solution. So I'll just warn you that one, this is not a problem I would throw at you on a quiz and expect you to be able to do it. First off, this took over 20 minutes on one problem. It's not fair to do it on a quiz problem, where I expect you to be able to do 4 of these problems in about an hour-ish. Okay. 2, it uses a whole bunch of math from a whole bunch of places, and you may or may not have ever been taught this. So if you're looking at it like, I don't know, that's okay. I don't do this to you guys anymore. And if it's going to happen at all, it's going to be something where you can do factoring by grouping. Okay, like if I asked you to factor the one up above, that would have been terrible. But if I asked you to factor something like that, right? X cubed plus 3x squared plus 3x plus 1. I mean, you should know, right? That's x plus 1 cubed. All right. There's certain things that you can factor that's not so bad, right? X cubed, say, plus 4x squared plus x plus 4. Again, or maybe put minuses in here. Okay, these are polynomials that can be factored by grouping very easily. I'm not going to apologize so much if you ended up with a problem like this. All right. But if I'm assuming that you're going to be pulling out that synthetic division and checking your rational roots and going at all without a calculator or all without like a, MATLAB or, some other fancy program, like, no, that's not right. So, don't, as a homework problem, this is fantastic. As a quiz problem, this is a terrible quiz problem. Okay. So I just want you to keep things like, this is where I am in my perspective of looking at, this differential equation of saying we have y triple prime plus 4y double prime minus y prime minus 4y equals some stuff. Having you do that, that would be fine. Because there's an obvious factoring by grouping going on here. Okay. Having you do the one we just did, gotta quit. That's too much. It's too much. Okay. And I don't like to do these anyway because at some point it's like, what am I grading? Okay, like how many steps is there for you to get from the beginning to the end? What am I grading? So you have to keep that in perspective too. Okay, this has been long enough. I'm going to go ahead and let you go here and upload this one, and I will see you in the next problem.